All right, so this lesson is lesson 104, and we are working with triangles here. There's a lot of vocabulary in this lesson, so I have some tips and tricks on how to memorize some of these things that are cringy. Just gonna tell you, not gonna lie, they're cringy. But hopefully they can help you in some way, shape, or form. And then obviously when we're dealing with shapes, this is some basic geometry. And then you're going to have to apply some of the things that you understand then about these different types of triangles to some critical thinking questions and figuring out sides and angles and all the good things. So the first thing is that triangles can be classified by two different ways, by angle or by side. Okay? And by angle, what we mean is the measurement of the angle. And there are three different ways that a triangle can be classified by angle. This is the first way, and this is a right triangle. Okay? It's not a right triangle, it's a wrong triangle. And a right triangle is defined as 90 degrees. That's the only triangle that can be a right triangle. It has to be 90 degrees, okay? And that means that the height and the base are perfectly perpendicular to each other, okay? So they form like an L. The second classification by angle is called acute. It's so acute, so little and acute. And that is defined as less than 90 degrees, okay? So an acute triangle can be from 1 degree to 89 degrees. And the third type of triangle by angle is called an obtuse triangle. It's obtuse. If you've ever heard the word obese, it usually means large, right? So think of an obtuse triangle as an obese triangle or a large triangle, meaning it is, I did this wrong. Less than 90 degrees. It means it's greater than 90 degrees, okay? Which means it can be 91 degrees to 179 degrees. Now, the book leaves out one type of angle. There's one more, and it's called a straight angle. It looks like this, okay? And its measurement is 180 degrees. So, all right. The other way that a triangle can be classified is by side. And what I mean by side is the measurement of the sides, okay? So this first one, let's look at it. It has an S next to it. It's called a scalene triangle. And a scalene triangle has three sides that are all different measurements. None of them are matchers, okay? So if you notice here, we have 1 tick mark, 2 tick marks, and 3 tick marks. That means that each of those have a different measurement, okay? So scalene, no equal sides. This kind is called an isosceles. Isosceles, okay? And if you notice, we have 2 sides with 1 tick mark and 1 side with 2, which means these 2 sides are equal and this one's not. So an isosceles triangle has 2 equal sides. Now this one is called an equilateral triangle. Equilateral, you hear the equa in there? It means equal, right? So an equal triangle, meaning that all the sides are equal. And if you notice, they each have 1 tick mark on them, which means they all measure the same. Okay, now here's my silly trick for how to remember what scalene, isosceles, and equilateral mean. Equilateral is pretty easy, but let's just review this. When we're talking about an equilateral triangle, we have 3 equal sides. When we draw an E, is it true that the 3 legs that come off the E are generally the same length? Yes, okay, so we have 3 equal sides, 3 equal legs coming off the E. When we draw an eye, is it true that the top and the bottom, the hat and the base for the eye are generally the same length? And the one in the middle is different, right? So 2 equal sides, 1 that's not equal. Now, how many equal sides do we have in an S? We don't have any, right? So that's one way you can remember that a scalene triangle, or a triangle that starts with S, has no equal sides. Now there's one more trick. You ready? It's a little song. Like to hear it? Here it goes. Isosceles, you look just like a Christmas tree. Is it true that an isosceles looks a little bit like a Christmas tree? Is it true that it has two equal sides and the base is different? Yeah, so those are my tricks. Right, 90. Acute, it's so acute, it's small. Smaller than 90. Obtuse. Oh, I didn't write obtuse. Obtuse. Obtuse is big. So it's bigger than right. Scalene, S, no equal sides. Isosceles, I, two equal sides. Equilateral, three equal sides. All right, hopefully that helps. Now, how is this going to be applied in this lesson? We have a triangle and we have to analyze using the information that we know to be true. And this says that this is 40 degrees. This says that this is 60 degrees. All right, and it asks us to find the measure of angle BCA. Okay, so BCA. So I'm going to highlight BCA for us. B to C to A. Remember, the second letter in that set for the angle is going to be where the vertex is. Okay, it has to be in the middle. So we could also say ACB, but we can't say BAC because that would be a different angle. All right, so now the other thing to know about, I kind of skipped over this. The other thing to know about triangles, and this is a universal truth for the rest of your existence, or until God changes this somehow. But anyway, for the rest of your math career, for all of eternity probably, a triangle always has the internal angles will always add up to 180 degrees. Okay? So I'm going to say that again. For a triangle, the internal angles will always add up to 180 degrees. So if we know two of the angles, we can find out the third angle by finding the sum of the two and subtracting it by the total interior angles of 180 degrees. So we have 60 plus 40. 60 plus 40 is what? 100 degrees. If we know the interior angles always measure to 180 degrees, we're going to subtract out 100 and we get 80 degrees. So we have that angle equals 80 degrees. So we would say angle BCA equals 80 degrees. All right? All right, let's do another one. We have a triangle that looks a little bit like a pyramid, ABC. We have, this is 50 degrees, this measure 45 degrees, and they want the measure of angle B. All right, so again, the sum of the interior angles of a triangle is always 180. So we have 180, and what is 50 plus 45? 50 plus 45 is 95, so we're going to subtract 95 to isolate angle B. So I'm going to say 7, 5, 17 minus 9, 8, 85 degrees. So angle B measures 85 degrees. We could say 85 degrees. One last example. It says angle B measures 110 degrees. Ooh, this is a good one. Okay, so we have ABC, 2 tick marks, and they say that B equals 110 degrees. So I'm going to label that myself. All right, so they have to add up to 180 degrees, right? So we know that there are 70 degrees left that we have to deal with, right? Because 180 minus 110 is 70. Now, because these two sides of the triangle are equal, it means that these angles are also equal, okay? So if we have 110 degrees here and we have 70 left to play with, sorry, it's hard to do this backwards, 70 left to play with, all we have to do is what? Divided by 2, right? So 70 divided by 2 is 35 degrees. So each of these are going to measure 35 degrees. Okay? So I'm just going to repeat that. If you have a triangle that's an isosceles triangle, right? It has two sides that are the same, one that's different. The opposing, how do they say it here? The opposite angles will be equal. And that's just a truth about triangles. I think we've talked about this. There's a whole study of triangles that you can take in high school called trigonometry, or you can take it in college. So they're all the same. All right, you have a couple practice problems on that. Please let me know if you need help.